Good morning, everyone. Now I tell about niobium nitride multilayer coatings. The work was we work with Olga Vasilyevna and have some results. To increase this survival life tool strength of survival life and strength of cutting tool, it is sufficient to form of hardness of super hard materials on this surface. The thickness of that coatings can be about 5 micrometers. The architecture of multilayer coatings can be different, such as multilayer with the same elemental composition entire of the thickness of coating. This is single layer and multi-layer with alternating layers of different elemental composition, and the gradient with the concentration of one element of coating will be changed. The aim of this work is to synthesize multi-layer coatings of metal ceramic system and reveal the influence of modes of vacuum arc plasma assisted deposition on the structure and properties of synthesized multi-layer coatings. In this work we deposition multi-layer coatings of the metal ceramic types with relatively sharp boundaries between the layers will be carried out at a constant gas pressure and mixture, and the concentration of gas ions of nitrogen will be with non-self-sustaining arc discharge. The research was carried out on a vacuum ion plasma installation Quinta. He have 5 plasma generators with different construction, and the computer system control which allows reproducing the thickness and composition of the layers. For ion plasma nitriding, for ion plasma assistance in vacuum arc deposition, the coatings, the generator based on non-self-sustaining arc discharge with the thermionic and halo cathode pink pair was used. Here you can see that construction. And for generator metal plasma, the DI-100 arc evaporator was used. The arc evaporator have cathode with a diameter of 100 millimeters, and he is in the his material is niobium. And this slide shows the diagram of experiments. The samples were fixed on a holder that was located on the center of the vacuum chamber of the 300 millimeters about plasma generators. Then samples were also fed with a pulse periodic bias. The coating was applied in the several stages. They are presented on this slide. To identify the necessary modes of obtaining multilayer coatings, we first synthesized and investigated on single layer coatings. Their thickness was about 3 micrometers, and the metal coatings applied without plasma assistance, and the nitride coatings applied with plasma assistance, and the current of the non-self-sustaining arc discharge was in 130 amperes. As you've seen, the concentration of nitrogen in our coatings will be higher than the coatings without plasma assistance. At the second stage, to demonstrate the effect of plasma assistance, we had developed and synthesized some multi-layer coatings of niobium nitride. At first, the total pressure was second please. The deposition was carried out in argon-nitrogen gas mixture with a total pressure about 2 pascals, and the pressure of nitrogen was 100 pascals. The current of arc evaporator was stable and not was stable. To get the nitride coating, we power on the generator of gas plasma, and to get a metallic layer, we powered off the gas to the generator of the gas plasma. In plasma-assisted modes, several types of niobium nitride coatings were obtained with different thickness. That's thickness of 10 nanometers and 100 nanometers. And we had the coatings by changing the current of gas plasma generator and changing the gas mixture. All of this, the total thickness of these coatings was 5 micrometers. To test the scalability of our coatings, we have the coatings of various thickness of here you can see the images of spherical sections of coatings deposited by vacuum plasma assisted deposition with different thickness of each layer. Here you can see every layer on these coatings, and here the thickness of one layer about 10 nanometers, and we can see that. And here the multi-layer coatings obtained without plasma assistance and with changing the gas mixture. The same images of transverse chips confirm the multilayer structure, and the thickness of coatings about 5 micrometers. From the result of the mechanical properties, it can be seen that the coating synthesized by changing gas showed poor nano-hardness, micro-hardness, and the low wear parameter. At the same time, the plasma-assisted coatings are twice as hard than Z coatings and 2 orders of magnitude more wear resistant. It was revealed by X-ray diffraction analysis that the coating consists of the following phases in multilayer coatings obtained by changing gases. Here, the content of niobium is revealed, and in coatings with plasma assistance we have lower content of niobium, and reveals the nitrate phase. Okay, thank you. The synthesized multilayer coatings have columnar structure, and the columns was in turn are composed on nanocrystallized, nano-sized crystallized. Sorry. It was found that niobium nitride coatings of different thickness have a similar tribological characteristics than the coatings with 5 micrometers thickness. In conclusion, using the example of a niobium nitride coating, the rationality of using the low inertia plasma-assisted vacuum deposition method for the formation of multilayer superhard coatings with high wear resistance. Thank you for your attention.